All right, awesome. All right, so we're going to start off with the bonus problem for the test, for exam 2. All right, and the question is, we have this triangle, right triangle, and we have A, B, C, and the question is, how do we go from there to the identity? How does that work? Okay, so what you're going to do is we're going to use the relationship of I'm going to kind of work through this with you guys myself, because I don't always do this, but we're going to basically take the Pythagorean identity and we're going to transform over here. So, and we're going to use like one of the tools we're going to use are like SOHCAHTOA. SOHCAHTOA is going to be one thing that's going to help us, and then just the regular Pythagorean identity. So we know already that a squared plus b squared is equal to c squared, right? And so you can already see the similarity, right? You can kind of already just see how that is possibly going to come over there and be that. So what we're going to do is we're going to just place an angle here so we have our bearings, so we have our perspective. Okay. So if we choose that as our angle, you can choose either side, not the right angle. We're gonna use SOHCAHTOA, and we're gonna say, hey, we're gonna say sine theta is going to be equal to what? What is sine as far as SOHCAHTOA is concerned?
Opposite over hypotenuse.
Yeah. So we're going to have opposite, we're going to call that b, over our hypotenuse, c. Right on? Okay. And now we're going to say, okay, well, what is our cosine theta going to be equal to?
A over C.
Yes, adjacent over hypotenuse. So we have A over C. Okay. Now, what we want to do is we want to isolate, we're trying to use these two things, this and these, to make a substitution to get to there. So what we want to do is isolate, because we have an A and we have a B, let's isolate these two variables. How would I do that? How would I get B by itself? How would I get A by itself?
Divide out the C.
Not divide it, but multiply. Yeah, because if I multiply C by this side, it cancels that out. So we're going to take both sides, and I'm going to multiply everything by a C. I put it the whole thing, so I'm saying C is multiplying here and here. Like that's just kind of how I write it. So anyway, so we know that C is going to cancel there, so we end up having C is being multiplied by sine theta and B, because it cancels that C out, right? And same over here, we're going to end up having a C is being multiplied by cosine theta equals A, right? All right. So now what we're going to do is we're going to substitute. We have a B and we have an A now. We know what it equals. So we're going to straight up substitute it into the Pythagorean identity. So I'm going to use a different color here, or we'll use a black color here. And so now what's going to happen is in A, I'm going to take A and I'm going to substitute it in there. So I'm going to have parentheses, because all of A is being squared. So all of A is being squared right here. So we have this, let me do it like this. We're going to have C times cosine of theta squared, because that's where my A is, right? And then we say plus whatever my B is right here, which is our C sine theta. That whole thing's being squared, right? And it equals C squared. See where I'm at so far? Do you see what we did? We took this relationship we knew about SOHCAHTOA on this general triangle, opposite over hypotenuse, adjacent over hypotenuse. We solve for our variable so we can substitute in, right? Because we know we need a sine and we know we need a cosine. So now we have a cosine, we have a sine. Okay. So now algebraically, this whole quantity is being squared. What is the algebraic thing that lets me? How can I simplify this? I guess is my question. We need to do a little simplification. What do we do?
Square.
Yes. So what happened? Yeah, square it. Yeah. And so what? So essentially, what I'm saying is this right here is one thing, and that's one thing inside of that bracket, and that's one thing inside of that bracket, right? Well, if everything's being squared, that means that this square can go to this one and it can go to that one. Do you kind of see what I mean? Because everything's being squared inside of there. So really, if we clean this guy up, we actually are going to end up having c squared times cosine squared theta, right? Plus c squared times sine squared theta is equal to c squared. Do you see what I mean? Yeah. So that was kind of like, I might not have been clear on how I was asking that, but yeah, it's squared. So if there was a 4 here and that was, cosine, then it would end up being 4 squared, which is 16 cosine squared, right? That's just how that kind of works. Am I in your way with it? Okay. And so now, well, look what happens. Like, I want that. I want this. What can I do right now to get that?
Subtract one of the c squared.
Not subtract, divide them off. Right? Because remember, on an equation, what I do to one side, if I do it to the other side, everything stays balanced. Well, so now if I say, hey, I'm going to divide every one of these by a c squared, right? So now those cancel, anything over itself is what? 1. And there we go. So we have cosine squared theta plus sine squared theta is equal to 1. And because, that one's sine squared plus cosine, but addition, what's true of addition? Does order matter? No. So we have our answer right there, and that is your bonus question. I'm going to make sure that's still in frame. Great, perfect. Okay. Radical, feel good? You feel like you got a safety net now, right? Okay, not too hard so a little bit of SOHCAHTOA, a little bit of algebra, remembering how to square, and then you divide off to get your 1. Boom. Nice. Okay. This I shall erase. Cool. So now you got a ace up your sleeve for the test. You're like, ooh, I'm gonna crush that bonus problem. And it was really nice of him to kind of like give you all a pretty clear idea of what that bonus problem is. I would say, be prepared for anything. I don't think he'll change it because he seemed pretty clear. So anyways, okay, let's start kind of just at the beginning right there. We'll say bonus right there. We'll start with half angles. Does that sound good? And we'll just start working through everything. Great. Half angles, 65. We're just gonna start with 65. And it's we have cosine theta is equal to -3/5. And then you have this statement over here where it's saying, hey, where 180, there's supposed to be a degree symbol right there, 180 is, to say the theta angle is in between that right there. And then they're asking you, hey, find sine we're looking for that guy. What do we do? What's the procedure? Don't know what to.
Would it be the 1 plus cosine?
Are you telling me this guy? So just, I guess, Fraser, because you're not. I think you're on the right track.
On the half angle, would it be? Or would it be? No, it would be sin. Or sin. Minus.
No. Okay. Here, let's get. So you were on the right track with the 1 plus thing. Okay. So first, like you can start anywhere. So I feel like this is a good place to start. What is our identity for sine half angle? Essentially, right? What else does sine half angle equal? Yes, I'm asking for the equation. Yeah. So it's imperative. You've got to know. Yeah, that one over there on the board that I've got. That's true. It is that one. But unfortunately, you've got to like this. This is why it's hard the memory work. You got to get it in there. So I'll just state it right here. We know that sine, or I didn't. I'll put that in this piece right here. So we know that our sine half angle. And this is where I break it loose. It's got a real specific feature right here on half angles. What is it? For the formula. Plus or minus, yeah. Let that kind of be, when you're memorizing, you got to create some kind of like roadmap in your mind for the memories. And then what comes after the plus or minus? Yeah, because in algebra, right, like plus or minus, there always seems to be like a square root thing. So you're kind of etching this in your mind. So anytime you see half angle, you got this kind of plus or minus radical thing happening, right? Okay, so we know that there's a quotient inside of there, okay? And you can kind of think of that, well, this is being divided, so that identity is being divided. You know what I'm saying? I'm just saying like landmarks, create landmarks in your mind. Now what goes on top?
It's 1 minus cosine.
Yeah, sinus gets the minus. That's what they, or like sine, even though people say sinus, even though sine gets the minus, but sinus gets the minus rhymes. People say that. It's helpful. So we have 1 minus, and you said cosine. What kind of angle's right there?
Would it be the -3?
Well, before that, we're just stating the formula.
Oh, theta.
It's just a theta. Notice now, okay, notice this is half angle, but this is twice that angle in there, right? Because if I multiply this inside by 2, the 2 goes away, right? And we just get theta. That's an important feature, and you'll see what usually I don't put that in that parentheses. Anyway, so yes, what goes on bottom? 2. Perfect. Yeah, and you can make a landmark. Well, there's a 2, there's a 2. Yeah, so that's great. Okay, so now we have one of our tools, and this kind of is giving you a hint now, okay? So, because right up here, look what we have. We have a cosine. We know what cosine is. Yeah? Okay. This happened to be a little bit of a shortcut, so I'm going to back up a little bit and go the other way. So now that we have this, what I would recommend your first step, and we were doing this on other videos, is to find out where this stuff is now. We know what sine theta half angle equals, okay? So now let's find out what this information is doing. So what do I mean by that?
Like what quadrant?
Yeah, all that stuff. What quadrant? So I would draw the quadrant like this, and where are we? Where are we at?
Quadrant 3.
We are in quadrant 3. Perfect. Great. Yeah, because we have, this is 180 degrees or pi, right? And then you have 270 degrees or 3 pi over 2 for your radians. All right, so what that means is we always draw our hypotenuse, you can only draw the hypotenuse, right, like in there somewhere, but our angle, where do I put my angle here or my angle here reference? And do I draw my triangle to this line or do I draw my triangle to that line, right? Which one is it? When I draw my triangle on this guy.
Would be up
up to this, the reason is our reference is always to the ground. You can think in reality, like I'm not walking on the wall or anything, right? Our perspective is always from the ground looking down, or from the ground like looking up. You know what I mean? So always from there. So our angle that is always between the horizontal and the hypotenuse that we draw. That's where our angle, so when we're orientating ourselves in the triangle and we're using the information up here, this is always our perspective from horizontal, in between the horizontal and the hypotenuse of the triangle. Okay? So now, how do I label this guy with that information over there?
The hypotenuse would be 5.
Perfect, 5.
And then the adjacent would be 3.
Yeah, the adjacent, so where's it at?
It'd be at the top.
Top. Is it just 3?
-3.
Yeah, it's -3. Why is it -3? Why isn't this one -5 and that one +3, right? Like, look at this ratio. Where does that negative go? How do you know?
Because cosine is negative in the second quadrant.
That's another great way to think about that. But that didn't necessarily ask my question. This negative, how do you know that the negative goes with the 3 and not with the 5 when I draw it on the triangle? Right? Yeah. Because because if I had this, that still will make cosine negative in the third quadrant, doesn't it?
Yeah.
Right? But don't do this, because guess what? In trigonometry, the hypotenuse, and this is also true with vectors, this hypotenuse is always positive, no matter what. Also, notice, if you think about this as an x and a y coordinate system, isn't this negative x values? It's -3. Yeah, that's another way to make sure you don't make that mistake. We're in the negative x quadrant kind of area. So you're thinking both rotations, and you're also thinking x, y coordinates. -3x. Yeah, that's the distance of that line. Great. Okay, so now, do we need to? Actually, I'm gonna make y'all, because it's good practice. Well, 2 questions. Do I need to find this side?
No.
Well,
You do, but it's.
Well, actually, do you? Like, do we need this for this question? We need sine half angle. Do I need this side? Because sometimes you do, sometimes you don't. So I want you to know, do you know why, yes or no, that you need the side?
Well, no, because the identity is cosine.
Yeah, and we already have cosine, so no. But for the sake of practice, we're going to find this side. And it's good practice because because sometimes you do, sometimes you don't. I just want you to know, like, when you can cut a corner or something. Okay, so find this side for me. And how do we find it?
Well, it's 4.
It's 4 because you know your triples, but you would use what to find it?
For a squared plus b.
Yeah, you would use that. Okay, now is this 4? Is that right? Is it? I want you to be confident with your answer. I think Layla already knows because we did this yesterday.
No.
Is this? Did you do?
Yes.
Is that correct?
Yes.
So if we had.
No.
Okay, so like this right here would be one of our sides. So let's say we're looking for that side. So we know that would be that we would have our hypotenuse squared, and then we'd have to subtract this -3 squared, right? Like eventually, like if you worked out your Pythagorean idea, that would be right. So you'd have 25 minus 9, right? 25 minus 9 over that square root. This would give you 16, which the square root of 16 is 4. Okay, but is that right?
No.
Why is it what? It's not right. Why isn't it 4? The direction. Remember with this, we're in the negative x. Isn't that negative y direction? It's -4. Yeah, you got to, and this is why you draw, because the reason why it's important is because, now check this, like find me, I know I'm kind of being long-winded, but it worked, it's just getting you, what if I asked you to find me tangent? What is my ratio off this triangle? Tangent is what over what?
Opposite over adjacent.
It is opposite over adjacent. So we'd have -4 over -3. Let's say, though, I didn't write that -4, okay? Right. So tangent is what in quadrant 3? What's it supposed to be?
Negative.
Wait, remember, we have all students.
Oh no, it'd be positive.
Yes, do you see why? If you don't have that negative there, tangent's doesn't have the right location, right? It's all interlocked, I was gonna say interlocked. It's interlocked. So you have to remember that you are where you're at, orientation of that triangle, okay? I just wanted to make that point real clear. Because we're talking little tiny mistakes like that takes you from that A, or potentially an A to a 70, I don't know, you're right, because it can mess a lot of stuff up. Okay, so awesome. All right, so now, but we're finding this, so let's find that. So sine half angle does what? How do we find that? All the stuff we wrote up there, how do we actually answer the question now?
What's the one?
Yeah, we just fill that in. So we have this plus or minus, and we'll kind of take care of that in just a second. So I have 1 minus, what is my cosine?
The -3.
You already got it there. Okay, so we have this -3 over 5. Awesome. 2. Now we're just kind of, and we know it equals this guy right here. So we just kind of solve this right here. But before we go on, let's continue on. Sorry, we'll keep this right here first. All right. So then 1, I would just encourage you to just make it, anything over itself is 1. Just make it that denominator. We know negative makes a positive, so we have positive 3/5. So we actually have, sorry, that doesn't look very much like a 5. But so we have 5/5 plus 3/5, so that's going to equal 8/5. Okay, with 8/5 over 2, and what does that equal? How do we clean that up? Complex fraction?
Would it be?
We have 4 over 2.
You said multiply the 2?
Right?
Sort of? Right, complex fractions sometimes mess people up. Do you remember how to clean these guys up? Remember, okay, and I'll try to make this more apparent. This is the big division, that's the small one, okay? So you always, so this is technically, 2 is the same as 2 over 1, isn't it? Right? So if we reciprocate that, 1 over 2, those will end up canceling, won't they? And what you do to the bottom, you do to the top, because 1/2 over 1/2 is still 1. We're not changing anything, we're still multiplying by 1. So then we have this expression here, and that ends up becoming where you can take that 2 and simplify it, it becomes a 1, and that cuts that guy in half. So we're actually left with plus or minus the square root of 4 over 5. Okay? So now,
Couldn't you take out the square root of 4?
yeah. Okay. So now, and also, how about we get rid of this pesky plus or minus real quick? How would we do that? Because remember what we're equal to, we have sine half angle. How do we get rid of that plus or minus? And you may not know this trick yet.
No.
You know, how do we get rid of that plus or minus on this half angle? Yeah, right? Okay, check this out. Okay. Well, I made sort of mention of it, but I don't think it had this much of an impact because our other identities didn't have a plus or minus built into the formula. You know, dude. So what ends up happening is you've got to know where sine half angle is. It's an all students take calculus type question. So sine is what here?
Negative.
Negative, right? But that's just sine full angle. We have sine half angle. Where is this? How do you find where the half angle is located? It's a much harder question. Or it's not when you know where to go, I guess. Okay, so I'll cut to the chase because it's like, okay, what you do is you take this expression and you say, hey, you go, I know that my regular angle is located here in this quadrant. Well, what if I just went, what I do to one side, I have to do to everything.
So it'd be between the 90 and...
Yeah, so you would divide that 180, it becomes 90, you got your half angle, and then what is 270 divided by this? I don't know how to. Somebody better at arithmetic than me.
135.
135? Yeah, I can never remember that. Yeah, you guys are right. I'm going to do it. Okay, so guess what? This is where our angle's at. What quadrant are we in?
So it'd be 2.
We'd be here. So sine is?
Positive.
Oh, that's how we get rid of it. Okay, so really, and we didn't really have to do this. I kind of made mention of this in one of the earlier deals, but it doesn't really drop the bomb until you have to get rid of this plus or minus in this equation. So know this. This is gold for these. This is a key feature because if you answer with the wrong sign, it's wrong, right? Right. Okay. So we know that, hey, this dude's going to be positive because our half angle is actually located up in quadrant 2. All right, so now that we got rid of that, now let's do what you had said. So what do we do now?
So it'd be 2 square root. Or, no, 2 divided by square root.
Well, you can distribute this radical to each one of those fractions, right? You can say the square root of 4 over the square root of 5, right? That's the same, correct? And we already know, we found that we already got rid of our negative sign. So now we have this. Now we just clean this up algebraically, right? Okay, so what does this equal?
The top would be 2, and then the bottom would be square root of 5.
Yeah, that's still this, but
Then you multiply the square root of 5 to the top.
yes, what is that called? We rationalize. We're rationalizing. Okay, so then so now I'm gonna come up here. Yeah, so we take our 2 over the square root of 5 and then we rationalize it by multiplying by an interesting form of 1, right? Anything over itself. That's why I love that concept so much because it's all you're doing is transforming something. It's the same idea when you're taking radians. Anytime you do any conversion or cleaning any, you're always multiplying by 1 because you're not adding any, right? So square root of 5 times the square root of 5 is 5, right? It just lifts that off, okay? And then what's up at the top?
2 square root.
Yeah, it doesn't really change, and there we go. And we know it's positive because we found out that our half angle is actually in quadrant 2. Don't let that mess you up, right? Because our triangle, the information we're using is here, but don't let that throw you off. You know, so kind of put a red star or something. Okay. Rad. Oh, and then let me put in. Tanner, did you see what time? I'm just at 6. Yeah. Awesome. Cool. All right. Feel good? Sorry, I kind of went long-winded, but like you have to know all that, right?
Like how to find if it's negative or positive.
Yeah, exactly. Yeah, because that formula has a negative and positive, and so you have to take care of it, right? So sorry for kind of going long through that or whatever, but you need it. So we're good here. I'll backspace delete. Yeah. Okay. All right. Awesome. Okay, let's, we're gonna hit the next concept. Now we're gonna find, we'll hit, this will be problem 69. And then we got sine theta is equal to negative 12 over 13. And then it's saying where our angle is going to be in between these guys. And we want to know, hey, find cosine. First step. And I'm just gonna say, first step, get this information first. That's what I would say. I'd say do the, let's draw out and see that before we do that. So we're gonna get in here to our quadrant. Where are we located? We're in radians, right? What quadrant are we in? Because
it would be 3.
Yeah, 3 again, right. Because pi is here and 3 pi over 2. So it's kind of like speaking two languages. Can you speak radians? Can you speak degrees? They're both, they're just, when they merge in your mind, you're like, yes. Doesn't matter what you see. So we're drawing a triangle. We have our hypotenuse coming out into the third quadrant. We always draw up to the floor, and our angle is always relative to the floor and our hypotenuse. So that's where we're looking at right there. Our angle's right here. Okay? And so now, using what we have in our problem, we label it. So what do we know about sine?
The hypotenuse is 13.
Uh-huh.
And the opposite is 12.
The opposite of that angle is
Negative.
-12. There we go. Yeah. Because even if you knew it was -12, but you just say 12, thinking and writing, you know what I mean? They sometimes don't. So just be so meticulous when you're, so -12. All right, awesome. So then, okay, so now let's now I would look at this and say, hey, do I even need to find the side or not? So what is cosine half angle? And this is a straight up identity question.
It's 1 minus.
Oh, but I'm gonna.
Plus or minus.
We're gonna go right here. We're gonna say, hey, cosine half angle is equal to, what do half angles always have? This feature right here.
Plus 1
Yes, it always has that. Then what comes next?
square root.
Yeah, then we have the square root, and then we know we have some quotient here. We know on bottom is a
2.
right here, but we know what one's here. This is the problem child. What goes right here?
Is it plus?
It is plus, because sinus gets the minus. Okay, so the other one is this, and then what goes right here? Which one?
Cosine.
It is. It's weird. They're both cosine. So just they're both cosine. Cosine, and then how much is this angle from that one? It's double whatever's here. And the reason why I make this point, okay, it's double this. What if inside, what if I had this identity, but I actually had, how much goes there?
Should be
8.
Okay.
Yeah, 8. Yeah, so you can use this in a lot of different ways. I just want you to know the relationship from here is double, okay? So that's what, that's a neat part about it. It's standard written like that. I just want you to know that that relationship is double. Okay, now let's move on. So do we need to find the other side of that triangle?
Yes.
Yeah. Yeah. Do you know what sign's going to be there already? Just so because it.
It would be negative.
It'd be negative. We're on the negative x direction. So I almost recommend that. Before you start doing your calculations to get lost, go ahead and just write your negative right there. Now, let's solve that triangle. We know that it's got to be, we know we're using a squared plus b squared equals c squared here. We know that, I'm just going to randomly choose, we know that negative 12 squared, let's say we don't know what our b is, and we know that c has got to be 13 squared, right? And now we're just going to kind of crush this. We got b is equal to the square root, I'm going to kind of just pick it up a little here, minus 144, right? Did I do that right? And then we know that this minus that, is that 25?
Yeah.
Cool. Square root of 25 is what?
5.
5. Yes. So, cool. So this goes here, and notice, and right, like we don't have the negative, but we already wrote it here, so we're like, oh, we saved ourselves. We saved ourselves a minus 2 or whatever. Okay, awesome. Right there. So now what do we do? I'm actually gonna make a little room right here. Our calculation eyes on the side of the page. We're good right there. Right now.
So now we just run the.
Yeah, now it's just plug and play at this point. We have equals. Would you like to get rid of that plus or minus right away? Yeah. How do we do it?
Divide that.
We take that guy. So we say, hey, this guy, we want the half angle, and we have to do everything here. So I'm dividing this, or you can also say, you can think of it as multiplying it by 1/2, right? That's the same,
Yeah.
right? Because this is really 1/2 times that 1/2 is the same as dividing by 2. Do you see how that works? Right. Okay. So now, what is our new identity? I say identity. What's our new? We know that our angle is now going to be pi over 2. Here, half angle. So what is this? This is. Oh, sorry. 3 pi times 1 is just 3 pi, and then 2 times 2. What quadrant is that located in?
2.
We are in 2. What is cosine positive or negative quadrant 2?
Negative.
It is negative. Nice. 3 pi over 4, what kind of angle is that? Off the top of your head. It's a 45-degree angle. Awesome. What is the degree in the second quadrant that's 45? Perfect. See, I start doing that. Kind of look at that and be like, what is that? Oh yeah, okay. And you go, count it. Nailed it. Okay, sweet. So we know that cosine is negative. So we go, boom, we circle that, we go ahead and just get rid of that guy. So we know that we have negative right there, square root. We've got, we know that cosine is what? We got a 2 right there. Cosine is what?
Negative 5 over 13.
Yes. So I'm going to just, and the reason why I said that is like, let's just transform that 1. Anything over itself is 1. And then we have plus, and we have our adjacent over our hypotenuse. Nice. So basically we're saying 13 minus 5. I'm terrible at that. What is that? 13, 12, 11, 10, 9, 8. See, I count on my hands. Negative. So we have 8 over 13. Catch me if I'm wrong. It's negative over cosine half that angle. Okay. Sorry, this should come down a little bit more, yeah, so it looks interesting. Okay, so how do we clean this guy up?
Multiply by 1/2.
Yeah, multiply by 1/2. We have 1/2. 1/2 over 1/2 is still 1. And so that gets rid of this guy down here. 8 is cut out, that goes to 1. So now we have this radical negative square root of 4 over 13, right? Okay, let's clean this up. That is the same as distributing that radical to both of those guys, right? So then this guy, kind of right here, becomes, it's equal to, we got a negative, square root of 4 is 2. Then we have square root of 13. And then what do we do to that?
Rationalize.
We rationalize it by multiplying by an interesting form of 1. And our answer becomes
-2 square root 13 over 13.
nailed it. We'll just double check our answers, make sure we didn't make a mistake. And did I write? Oh no, we're looking at the. Okay, whew, I looked at the wrong problem. I was like, what? I was like, there's no way. Okay, awesome. We're good. Sweet. Okay. Let's keep it moving. Okay, and as we're moving through these, this is just more of the same, right? Just more of the same. The procedure is exactly the same every time. The only thing that changes is the trig function. So really, the keystone is, do you know your half-angle identities in this section? In this whole section, do you just know your identities? Okay, so we're here at 73. And we have, oh no, did we just do? No, that's right, yeah. 73, we have sine theta is equal to 12 over 13. And then we have where 90 degrees, the angle is in between these 2 degrees. We were looking for this bad boy. First thing we should do,
Decide what quadrant.
yeah, just get your orientation down. Just be like, I think that's good. So where are we?
Quadrant 2.
Quadrant 2. It's like the label. We know where I've been here, we go to yacht. And you don't have to be specific, just draw a generic triangle in there. Our reference angle is always to the perspective of the floor. All right. Now how do we label that guy?
The hypotenuse is 13.
Uh-huh.
And the opposite is
12. Just 12, right?
yes.
Right, because it's in the positive y direction. So it's just, and it makes sense, right? Because sine is positive in the second quadrant. Okay, now this beast. What is the what is that guy?
Wasn't there 3?
What's that?
There's 3 different.
There's 3. Right? Which one do you want to use? Which one sticks the best? You can use any of them.
I don't know. I just know there's 3. I don't know.
There's 3. I think the easier one, I would pick like, let's take this. To me, the easiest one to know is the one that looks like the other ones, because there's one with the radicand and the other 2 don't have it, so they kind of look weird. But this guy, what do we know? Tangent is typically sine over cosine, right? Well, sinus gets the minus, right? So the one that was representative of sine goes on top, and the one that is representative of cosine goes on the bottom. I think that's easy to remember, right? Because you knew that the 1 plus cosine was associated with the cosine half-angle identity. We know that 1 minus cosine is associated with the sine. We know that tangent is sine over cosine.
Oh yeah, that's easy.
Yeah, that sticks real nice. It looks better than, I'll just write this one. It looks better than sine over 1 plus cosine, doesn't it? And then even worse, 1 minus cosine, it's still sine down there. What does that mean? Those look terrible. I mean, just kind of, I would pick one and just work with it, because you're going to get the same answer. It doesn't matter. Pick one. I think this one, because it follows the same form. You have the plus or minus, you have the radical, sine over cosine. I think that's the easiest way. Okay? So now, do we need to solve the rest of that triangle?
Yes.
We do, yeah, because we have a cosine angle. So it's the adjacent. We're missing the adjacent. So we find it. We crush this one. Do you already know what it is? It's 5, right? That's, that's not bad to know, but is it just 5?
It's negative.
It's -5 because negative x direction. Don't forget that, okay? Because cosine is what in quadrant 2?
Negative.
Negative. So let those associations catch your mistakes. I know if you get a positive ratio and we're talking cosine, you're driving the other way, right? You're not getting to where you need to go. Okay, so let's just plug it in now. So we know that we have, or actually let's get rid of the plus or minus. How do we do that?
Where it is by 2.
Yeah, everything by 2. So we know this guy now becomes 45 degrees, right? 90 divided by 2. We know that this is just our angle that we're looking for, and then 180 divided by 2 is
90.
beautiful. Where are we at?
Quadrant 1.
We're in quadrant 1. Isn't that wild how that does that? It's cool, right? Okay, so we're in quadrant 1. So what's true about quadrant 1?
It's positive.
Everything's positive. All students take calculus. All is positive in quadrant 1. So we know that we're going to be choosing that positive sign. Feels good. I like to take care of the signs. Like it was kind of like right here. You could have already written the minus sign when you fill it. You know what I mean? Do the signs first sometimes. I don't know. Okay, so now we have what is cosine now?
Negative 5 over 13.
Awesome. So I'm just going to go ahead and go 13 over 13. 13 over 13. We know we're using both of those. We have a minus 5 over 13, the adjacent over hypotenuse, and then we have plus 5 over 13. And then this extends down. All right, now it's just algebra. Now it's just fixing it. So what do we say? 13 plus 5 is going to be 18, right?
Yes.
So we have 18 over 13, because a minus and minus is a plus, and then we're also adding right there. So we have 18 over 13, huh? That happens. It's 1, right? Anything over itself is 1. The square root of 1 is 1.
Wait, but how did you get on the? I thought it would be wouldn't it be negative 5? On the bottom.
On the bottom?
Mhm.
Oh, I'm wrong. Good job. Nice. Nice catch. So now, that's not that. We have 8 over 13, don't we?
Bless you. Thank you.
And you see how easy, I mean, shoot, I made mistakes too. I would have been, so now what do we do? Yeah, we multiply by the reciprocal, right? To get rid of this guy on the bottom, because we don't want a complex fraction. We just want this. So 13s cancel, the 8s cancel, now we're up here. 13s cancel. You can divide those two guys by 2. We get a 9, we get a 4. So we're left with, all this stuff ends up becoming 9 over 4, right? Square root. Correct? Okay, so let's clean that up. This one's kind of nice, right? Because you can distribute that right there, right? What did that become?
3 over 2.
3 over 2. And we are done. Go. Cool. Okay. Now we are, and now this stuff is this next one's a little hard for me. I don't think there's going to be a ton on there, but the product to sum and sum to product. I'm gonna have to look at my notes for some of these because I don't know those. Those are the only identities I don't know off the top of my head. So, but if it's any solace, I've done all the math up till Cal 3, and I haven't used those a lot. So let that kind of make you feel good, like you know. But I have a Sinking suspicion, you're going to see those in dynamics for some reason. I don't know why. I think we're going to get there. So nice. We're done with all the half angles. We'll crush that. So we are on to product sums, sums, and products. We're going to get 77. And then again, just stop me, like I'm just kind of trucking through it, but like, if y'all have questions or specific questions. I did the bonus question earlier on the video to how to do that proof. So like, and I'll timestamp it so it's easy to get to. It won't be annoying, hopefully. 75. Okay, and then we have cosine of 66. And I might show y'all a little thing that it could save you here. Okay, how to do this. So this is product to sum. I want to show you it'll maybe help make these stick. Okay. We know that cosine, if I was to let's just say this was like one of our generic formulas that we know. Let's say I say that's cosine alpha times cosine beta. What part of an identity do we know that this is? I'll just lead you to it. It's like a product or a sum identity. How would I complete this? It would be like, let's say it's a product, and I say plus. What goes on this side? Sine, you said alpha, right? Sine beta, okay? So we know it's that, right? Well then, and we know that equals our which identity? Right. Well, this one specifically is minus, isn't it? Because it changes, it switches. Okay. Well, now check. And so just real quick, we're going to state the other one. We know that the other one is just. I know this is long-winded, but it's going to hopefully help a little bit with your memory. We know that the signs flip, and we have this, right? We got that, right? What if I was like, hey, I want just the cosines by themselves. What if I turned this big thing into its own equation to get these by themselves? Wouldn't I just add this whole row to this top row? The plus and minus would eliminate those. I'm left with cosines. Do you see what I'm saying? So this ends up coming down. We say now, like if I was to add everything down, we would have cosine alpha minus beta plus cosine alpha plus beta would equal, the signs would cancel off, and we would be left with 2 of these cosine alphas, cosine beta. Do you see what just happened? I turned this into a giant equation. And now look, I want my cosines by themselves. What would I do? You divide it off by 2. Do you see that? This whole thing divided by 2. Voila, we have our formula. Right, now we have our formula to what that equals. We have, and I'm just going to kind of flip the sides here, we have cosine alpha, cosine beta is equal to the cosine of the angle, that guy, cosine of that angle. This is your identity. You see what I mean? It comes from taking your sum and difference, isolating one of these guys. So all those, remember when we were learning these, they're real long, complicated, they look weird. Is it a plus or minus here? Is this one before that one? Is that one? That's how you figure them out. If you get lost, you can use this. It's a long way to go, but let's say you're looking at that and you go, I got nothing. You can at least know where it comes from. Okay, so I'm going to erase all this. This is our formula, and now we're going to solve that. So we go, actually, I still have some space. Let's just leave it up there so you see how it progresses. All right, so now what do we do? Oh, and I forgot, this is supposed to be, oops. I didn't do my due diligence. This whole thing is over 2. There we go. That's our formula. There we go. Don't forget that. Okay. Or you can think this whole thing is multiplied by 1/2, which I think is how formula is actually written. It's got a 1/2 just multiplied by everything, or everything over 2, right? It's the same thing. All right, so now what we do, we just plug and play. We know that this guy is actually our 75-degree angle, and we know that guy is our 66-degree angle. So we just put it in there. So I'll kind of go to blue. So we're going to take this side and plug it all in. We got cosine of our alpha angle minus our beta angle plus the cosine of our alpha angle plus our beta angle. Everything is being divided by 2. Okay, so now we clean it up. 75 minus 66, I'm not good at that. 75 minus 66. Gives us 9. And then we get cosine, then we get 75 plus 66. Gives us 141. 141. Have that over 2. Okay. Is 9 a special angle? No. Is 141 a special angle? It's not. The question, it doesn't say exact, but this is an exact answer. What if I asked you to give me the decimal answer? What would you do? Put it in your calculator. And make sure your calculator is in degrees. And okay, so if you're, so the lesson is, if you don't have special angles, this is your exact answer. If it's special angles, then we would put the ratios in that our special angles give us, and we would do a little more algebra and so on. So this is our answer.
And then that trick you did, can you do it for all of them?
Every one of them. But it takes a little thinking, right? Because the only identity that has cosines together is cosine, sum and difference. So all you do is you take your sum and difference and you figure them out. The sine and the cosine, when they're mixed, that's when it gets a little like, but this trick works every time. In fact, it's not a trick, it's the proof. We just did the proof of it. That's where it comes from. We're just isolating those product to sum.
So sine, you would just do sine for the addition one and then sine for the subtraction one?
Yeah.
Okay.
And it's like, it's easier to just to work with it. You know what I mean? To just find one and do it. But yes, it's like the same concept. Yeah. But sometimes you're subtracting them and sometimes you're adding them over here. You just have to know what you're trying to get. And it'll change this sign, and that's what will change that outcome. You saw all those formulas where it's negative or positive there sometimes the positive one's first and the negative one's second. It all has to do with how you're isolating this big equation. That's how you solve that. Okay, I'm gonna erase this, we're good? Sweet. All right, yeah, these guys can get hairy. These guys will show up in calculus too, these formulas. You'll need them for integration. They are coming back. Nice. Okay, so I think we should do the sine one, like just 77 and 78, because it's sine and the cosine. Or do you want to see how it works with sine, or are y'all good? Cool, because we're also, how late is everyone staying? That way I'm not like keeping
I'm
them.
really gonna stay for this one.
And then bounce. Let's do a new one then. We'll do a new one because the sine is the same one. It's the same technique. Okay. All right. So let's actually move on. And then if y'all need it, email me, and I'll like post an extra one or something. Okay. Now we're gonna go. So that was product to sum. Now we're gonna go the other direction. Sum to product. 79. We've got sine 4 theta plus sine. And now this one I'm probably gonna have to look at my notes. And we got 10 theta. Because this proof's a little longer. But okay, so these guys, you just have to know your identities, which I don't know mine that well. So I'm gonna pull those up. This is what I need to practice as well. So our sum is going to end up being, I'll write the formula, that way you can see the formula. You have a sine alpha plus a sine beta. Oops, that is not beta. Is equal to, this is your proof, 2 sine. When we were doing these in class, I was doing the proofs. They're not super long, but I don't think it's helpful. Even if I showed you all the proof, I don't think it's actually that helpful. The proof isn't even that helpful. These are just, you gotta memorize these, unfortunately. Well, not unfortunately, they're gonna be good. So that's that. No, okay, the one association, you know that sine, I'm going to make an association. If, let's say, this will be a quicker proof. Let's say that I had sine theta plus sine theta, right? Let's pretend that this isn't correct, but let's think of it as it's a double angle. The double angle of sine is equal to 2 sine theta cosine theta, right? 2 sine theta, just a crazy theta, cosine theta. That's kind of its relationship. So if you see an addition of 2 sines, know it's loosely related, because this isn't a proof, so this isn't like right, but like I'm just trying to create a roadmap. Okay, if you know this identity, you can kind of surmise that it's that, okay? Just, that's how I'm gonna memorize it. All right, so it's related to the sine double angle identity. You have 2 sides. Okay, so now we're just going to plug this guy into that. So we're taking this one, and we have 2 sine. Our alpha angle is, that's not 40, but 4 theta. And then our beta is 10 theta, yeah, over 2. And then we have our cosine of 4 theta. Do you see how this isn't even any work, right? This is just memorizing. Like it's really not any work, right? That's what's going to be hard about that. I don't think this one's going to haunt you in your exam, because that's why I asked in class, because he didn't even really mention it that much. It may be in one of your simplifies. So if you're gonna spend the least amount of time on something, probably these. Okay, nail everything out. Let this be the last thing you study. Would be my, but take that with your own advice, because if I just told you something wrong, just, caution. Okay, so we just clean it up. 4, that becomes 2 sine, right, 14 theta over 2, right guys? And then cosine, and then we're gonna have a -6 theta over 2, okay? Let's do a little more cleaning up. What does this become? We got 7 theta. And we have cosine of what's over there? Okay, now we got it. Let me see if you can clean this up farther. Let me see what he did. I'm gonna make y'all go farther anyway, but what is it, something else? Okay, all right. Yes, this is your answer. I'm just gonna push you a little bit farther here, because I just wrote down. What is this also equal to? Because you do have to know one of these. This is a sine double angle identity, isn't it? So, well actually, no, it isn't, because the angles have to be the same. You're good, this is done, I'm sorry. Yeah, if these angles were the same though, you would rewrite this as a sine to whatever that angle happened to be, right? 2 times whatever you got in there. Okay, so, but that's not, I'm just, if the angles are different, you stop. If the angles are the same, you go. farther. Okay? All right. Cool. You're out on? Nice. All right. And then, let's see. Okay, nice. All right, sweet guys. Yeah, those guys are a booger. Okay. The proof this way to the other one though, that trick I showed you, not the same. Okay, so you have to do a bit more. It's not helpful to know it, but if you want to know it, I'll show it to you later. And Layla, if you want to know that too. I know you're not going the engineering route, but if you want to know how to prove those, it's not important for. It's not going to help you because it's long and arbitrary, or it's not long. It's
So I don't even know what the pharmacy.
no.
Boom.
Yeah.
Now I know where.
Yeah. Okay. All right. Let's move on to product to sum and summing to product exact values. Okay. Yeah, and then we'll be into rotations, and then I'll show you my way of rotating. Are y'all planning on staying longer too? Because I don't want to keep y'all longer if you don't.
Just a 7.
Okay.
I gotta
Nice.
be safe on the way home. Don't want to crash.
Yes, be safe. Okay, let's, well, how about let's go ahead and get into rotations then, because all this 81 is what we just did, but special angles, and you're just finding exact values. So it's just everything we just did, but what you've got inside the angles is something you know, you put the ratio in, you solve it algebraically. Cool. And then if y'all have problems with that one, just hit me up. But I'm not going to harp on those because I don't think it doesn't seem like he's going to, really. So we'll hit 89. Okay. All right. Or should we do one though, guys?
Sorry, I can't see what
Should we do one, or no, one of the exact values? Product to sum.
I'm okay.
Okay. You good? Okay. All right, sweet. Okay. And we are on to rotating stuff. Okay, sine, negative. Because this might be helpful for you to see how I do these. They're just a little bit different than how Vargas is doing it, but don't let me throw you off if you've gotten real accustomed to his way. Okay, mine's just going to have a slightly different. Okay, so we're looking for everything that's in between 0 degrees not included at the 360. That's what the inclusion of the 360. Okay, just make sure you look at that on your directions. Okay, now it's saying the angles right here. These guys, the square root of 3 over 2. This one actually should be kind of fast because is the square root of 3 over 2, is that a special angle?
Yes.
It is a special angle. If it's a special angle, because this is what your question was, right? If you see the special angle, can I just crush it?
Yeah.
The answer is, you know what? Email him. I'll email him too. I'm going to say yes. If you have the special angle, use that. Crush it. Be done. All right, so what is it? Like I would just kind of reference it. I put it up here. Sine is negative in which quadrants? 3, 4. We know, yeah, so we know we're looking here and here. And then what ratio would give you that angle? What angle would give you that ratio? Negative square root of 3 over 2. Do you have it in memory? It's a 60-degree angle. Oh, it's not really. I mean, it kind of is, right? Like, all it is you're saying, we're in these quadrants, right? So we know we have, I'll kind of draw it a little better. So, we know that we have a 60-degree angle in both of those quadrants, right? The reference is a 60-degree angle of some kind, right? We have some kind of 60-degree angle. So what is my 60-degree angle in a reference angle? What's my actual angle in quadrant 3?
No. Yep. Yeah. No.
240.
I didn't
Well, you can add from a 60 to 180. That'll get you there, right?
I didn't subtract 30 from 270, I subtracted 60 from
Yeah, be careful because remember our relative angle is always to the horizontal. We almost never calculate here in trig. You will in statics and stuff. Okay, so what is this angle? 300. Okay. If I was to rotate that one more time, is it going past 360? Yeah, if I rotate that, it goes past 360. Your answers are those two answers. So this problem, this isn't showing you how to do them, but this is if you have the special angle down, crush that. You know what I mean?
So if we get like the two answers and we know how far apart they are away from each other, can we just find one more answer and then add?
They're not really okay. So this is so be careful. These have, as far as their rotation, have nothing to do with this angle in between them. It has everything to do with, because you're like, we need to do one more so you can see the two different equations happening, because this guy is rotating by itself here and this one is rotating by itself here.
But they're both rotating the same amount, you know?
It's true, but don't think of it that way, because it will get you in trouble.
Okay.
There are two different angles that are rotating the same amount, and just disregard the space in between them. That's how I would recommend you think that way. Because when you get to tangent and cotangent, that'll throw you off. Is why I say that. Okay? So that one was easy. Okay? Let's do one that's gonna actually make us work for it. Okay, let's do no. There we go. We're gonna do 94. 94 is gonna have some stuff in it. So we have 1 plus sine theta is equal to 3 over 2. Okay. And then all of our stuff is going to be between that guy. Okay, so what do we do? Yeah, you want to start isolating this guy. So we're going to say -1 on both sides, which I'm just going to write it like this, right? Because -2 over 2 is -1, right? I just made the denominators look the same. I feel like those little things, just, you don't always need to you can turn ones into anything, as long as it's self over itself. So we have 3 minus 2, which would give you 4.5, right? This one sort of made us work. This was still easy. We'll go to the other ones as well. But right here, is that a special angle? It is a special angle. So what is it? It's a 30 degree. Yeah. So one of our angles is 30 degrees. Our other angle is what? Because sine is positive in two places.
1 and
2. Okay. What is my 30 degree reference angle giving me in quadrant 2? 150. Okay, 150. If I was to do a full rotation, am I going outside of my bounds? Yeah. So these are your answers here. Okay.
Wait, are these kind of like the ones we were doing at the end of class?
Yeah, a little bit. Let's do one where the inside of the angle's messed up. Because these are going to be hard. If there's nothing inside of that angle, you're looking pretty for the most part. So that's that. But let's move on to one more so 95. Here's where it'll get. So now we're gonna get some stuff inside the angles, which is gonna finally give us something a little bit. Okay. All right. Do you give me permission to take you down my way? Or do you want me to reinforce Vargas's process here? This is up to you, because you got a lot of his process. You can see mine here, and you can it's because I'm afraid to show you because it could hurt you or it could help you. I don't know. Show you. You want to see mine? Okay. All right. So what I'm gonna do is I'm gonna solve this. So I'm gonna make a point about how Vargas is doing. Vargas would multiply both sides by what? What would he do? Arc sine. Okay. I'm gonna do it by substitution. I'm gonna say, hey, let alpha equal this inside stuff. Okay? And so then I end up restating my problem now, because I let this substitution happen. So I say sine alpha is equal to -1/2. Do you see what I did? I did a substitution and I made it look better. But don't forget, you need this. Okay? You're going to need this in a second. So now, this is a special angle, isn't it? You see what I did?
Yeah.
All of a sudden I just reduced it down. What is my angle here? Like sine is negative where? 3 and 4. What is my what angle is this referring to? A 30-degree angle. What is my 30-degree angle reference in the
210 and 330.
and we get 210 and we get 330. Do you see? Okay. Right? We got those. Okay, now this is where my technique's going to come off, change up a little bit. Okay, so now we have to put our substitution back in to make it make sense. So we know that our angle, we know that we're going to have some angle and it's going to rotate 360 degrees, and instead of n, I'm going to use k, like some number of times. Like angle just rotates. Well, we've got to substitute back in, so that our angle is like this. We have two angles. So we have two formulas that come up, and then we have to make them equal this. So 3 theta plus 135.
Set that equal to 210 and 330.
Yeah, exactly. And we have plus 360 in our rotation. And then over here, we have that other rotation, 135 degrees is equal to the 330 degree plus 360 rotation. Okay? And now we solve for our theta. So now I move minus 135 over, minus 135. This is going to give us 3 theta is equal to 210 minus 135. Gives us a 75-degree angle plus 360 degrees right here, like that, right? And now we have to divide by 3. This gives us our theta, and then 75 divided by 3 is 25 degrees, plus, and then that should be 180, right? 360 divided by 3, 120, 120 degrees, okay? Do you see? All right, so now, and then we do that process really quick over here. So we take minus 135, since it be 3 theta is equal to 330 minus 135 gives us a 195 plus 360. We divide everything by 3. We get theta is equal to 195 divided by 3, 65 degrees plus 120 theta. And then you use this formula to generate however many happen before 360. So you would say, so then you would make k is going to be equal, k, let me actually write it down. So now k is equal to 0, 1, these are just our rotations, right? However many out. So now what we do is we say 25 plus 120 times 0 is 25. So one of our answers is 25 degrees, right? And I'm just going to kind of draw a little bit like this. And now we rotate it once. We say 25 plus, and what makes this nice is you can just enter this in your calculator. You can actually put 25 plus 120 and then put a parentheses, and you can just count them up. So then our next angle, 145. And then we take that same, we can just copy and paste. We take that same formula, we put a 2 in there. That gives us a 265, right? And then we go up until we violate our, our domain restriction. And then, and we take that one, we put a 3 in there. We get a 385. And then that one is, boom. Okay, so we have that many right there. And then we take our next one and we do the same thing. We say 65 plus 120. And of course, if you put a 0 in there, your first one will be 65. I like this because you have this formula. Just instead of like rewriting it, you just make these two formulas and you just plug in 1, 2, 3, 4. You just rotate them. So then we put in 1. That gives us 185. You grab your formula, you put a 2 in there. You get a 305. And then you got this guy, and you put a 3 in there. You get 425, and that violates our domain. And then our answer. Bam. So you can solve it by how Professor Vargas, where you use arc sign, or you can do it by the substitution method. And you just have to know that, and this is the same thing, you're taking your angle and you're just rotating it. That's what this formula means. Whatever the angle that you found, your normal angle, it's just rotating. But then, as you know from graphing, right, this is a horizontal shift to the right, and our period is being affected, right? Well, it's not 135, you actually have to factor the 3 out, right? So that's what's changing all that. That's why the numbers look so weird. We have these weird rotations. And so what we're doing is our this division is changing our period. Our period is 120. So you actually see the period change in the formula, right? And then, so that's how I do it. So I wanted to show you all that. And we can go through Professor Vargas's way as well. I just wanted to show you, like, this is how I learned it. And for me, it's less writing. It's kind of like what I did with the graphing, where you kind of get all the stuff done first, and then you do one thing. You get to a point where you just add. Here, it's like you get everything, you just multiply by 0, by 1, by 2, rotate. All you're doing is you get your formula and you just rotate. Yeah. So take it or leave it. That's one way you can do this. Right on? And then you don't have to, you're good if you're ready. Sweet. Was that helpful or was that not? Because do what feels comfortable. Don't. I just wanted to show you this other, just in case if something went click or whatever, or if this was like, just wipe it out of your brain, like I didn't show it to you.
Okay, bye besties. Have a good day.
Later. Yeah. Does that? How do you feel about this? Is this like kind of like a did I make a mistake by showing you guys this?
No. I feel like it's better because you're like setting up for equations where you can just plug everything.
Yeah, you just plug because that's how I also did the formula. Remember how we did the graphs? I just we did this, we went ahead and shifted, we did everything, and then we just we made it real, like step by step and real formulaic. It wasn't it was reducing the amount of writing and creating, because all I'm doing here is I'm creating two formulas that just generate all my angles. You just have to remember to do them, right? See, we're setting up, we put our angles that we found, right? And then we have to adjust our substitution because right here we did an adjustment. We made all this just equal some regular angles so we could see what it looks like. But then we have to manipulate it back and solve for it, so then we have our actual equation, right? Because look, our angle changes because of the stuff inside, and then we end up having our period changes, and this changes our period. So you actually kind of, for me, I like it because I can see the period change, you know? And I'm not trying to remember rotations. I actually have the rotation value in the problem itself. Whereas, which is fine as long as you know it's rotating. And Professor Vargas was just letting you know that an n number of times, but it wasn't actually in the problem itself, right? Like you had to remember it. So it just kind of depends, like there's not a right way to do it, a wrong or a right way. It's just, this is how I learned it. But we can certainly go through Professor Vargas's way. I just don't want to like, it's really your call. Like I don't, because like if this is helpful, good. If it's not helpful, then we'll go back the other way.
I think I just need to look at it a little bit more.
Yeah. Yeah. Because mine, the step, it never changes. You sub, you see what it is, you get it, you know it's rotating 360. At least this period, the normal period, the standard, you split it up into two, and then you sub back in what you got, and then you'll have one of your angles, your other angle, and you just solve. You can do this exact step-by-step every single time, and it'll generate your, for sine and cosine, and cosecant, secant, technically, but not for tangent. Remember, it's different, because the period here would be 180. And you guess what's really cool about tan and cotan? It's less work. You only do one, because since it's rotating 180, your next rotation is going to hit the other one. So for tangent, you do this, but it's 180, but you just pick the smallest angle and you just rotate. Done. That's the difference with tangent. So it's actually less work with tangent. Right on? Cool. Well, we can, let's see, we're at 7 o'clock. We can continue on, or it's up to you. This is your time.
I'll probably just try to work on my problem.
Okay. Do you want to work it on your own, and then?
Yeah.
Okay, cool. Well, then I'm gonna turn this off, and that'll be that. I'm going to. All right. Awesome.